Hey everyone, Jason here. Today I'm going to be working on an iPhone 6 that was sent here for no image. I have dug into this one a little bit and I did a little bit of checking at the pins and decided this would probably be a good one to record a video on. It's probably like my third or fourth video on this same exact short, but I've sort of changed the way I troubleshoot it just a little bit differently, and well, I actually changed the way I repair it. So let me show you what I'm up against. I'm going to go ahead and I'm going to hook power to this phone in a way that you'll be able to see the current consumption. And see, here is the iPhone 6 with the best test screen that I have right now because my wife now has the only unbroken screen that I had. Now it's time to order some. Alright, so I'm going to hook the power supply up here, and with the supply hooked up and no button press, we're getting 0 amps. Now I'm going to press the power button, and I'm going to hope I didn't grab the housing that has a faulty power button. Wait. Customer's housing. We should be in good shape. Alright, so we get a 1/4 amp. I'm going to let off the power button. Are you kidding me? Ah, this phone. Are you serious? Right? Did I grab the right phone? Ooh. Yeah, this was sent here for no image. Let me tell you what happened with this phone. This is a repair that if I put this all back together and send it back out, this is going to come back to me. Like, this would come back. So we're at a 1/2 amp. We're still booting. This thing fixed itself. I discovered this one yesterday evening and decided I would save it for this morning. It'd make a great video. Yeah, and here's what I get. This is what I get. A phone that fixes itself. And you know what's something about phones that fix themselves? They'll break themselves too. So I'm going to wait for this to start all the way up, and then I'm going to tell you what I plan to find. Any minute this screen is just going to like stop because this thing had a solid short on one of the 5v7 lines. Okay, it did shut off, but that was a reboot. That wasn't a no image situation. So here's what was going on with this one. I swear it was not working. This was yesterday evening. It's like, hey, that'll make a pretty good video. I'll do that one. I'll do that one on camera. Well, this is nature's way of telling me not to record videos today. I should be getting work done. Okay, so I'm going to switch you over to the schematic here on my screen. We're obviously not going to need, let's see. We're not going to need the microscope on there for a minute. We don't even really need me on there, I guess, but we'll keep me on there. Let's zoom in on J2019. What I wound up doing on this phone, you know, the first thing I wound up doing is checking for long screw damage. And by long screw damage, I'm not talking about a duration of time, more a depth of the screw. And so I checked for long screw damage, and then I checked the image power lines here. You know, this 1V8, you're probably better off just to check the filter for continuity or just replace it for the hell of it. Because if 1.8 volts is missing altogether, you've probably got much larger problems than no image. And I also, from there, I dig in and I check these two 5v7 lines. And what I found out is that the first one was a normal resistance to ground. It was like, what, 50K or something? I don't remember. But then the next one here, pin 26, was actually like 0.07 freaking ohms. And of course you're not going to get an image with one of the chestnut, you know, one of these image supply lines at 0.07 ohms because chestnut's not going to be on. I imagine it's going to just go like, it's going to sense some sort of overcurrent and it's going to kick out. I've never actually seen a 5v7 filter blown, but I'm sure that it happens. The 1v8 filter seems to blow frequently. At any rate, I should not say I've never seen one of those filters blown. So many phones. So this line was freaking shorted to ground, like no image, shorted to ground. And now that I've sat down to do a video here today, I thought, you know what, I'm going to go ahead and show them what a no image power consumption boot looks like. And this thing booted. Alright, so let's take the screen off of it. Something that I know about this is that it'll do it again. Like if I just bank on it and I say, okay, this thing's working, send it back as a no fix. You know, don't charge them for it, or you could charge them $100. No, not me. I'm not doing that. So my assumption here is that this thing fixed itself. It's also going to break itself. Let's go ahead and take a couple of measurements and see if we can find anything crazy, because, you know, it's possible that we could be just like partially shorted on chestnut and the thing works for now. So let's go ahead and check those lines anyway. I'm going to take you with me here under the microscope. And let's make sure you can see my multimeter. When I touch my probes together, I am getting 1.2 ohms. So let's just assume 1.0 ohms is 0 ohms. And we're going to get in here and try not to stab the battery with these sharp probes. Well, semi-sharp probes. They're not as sharp as I'd want them to be. So here was my initial steps. I started here along the left-hand side, and I skip up here and I check these 5v7 lines. This one is reading 26.3K. Or wait, no. What am I talking about? It was 26. And they behave like that too. When I let off and I went back on with the probe, it'll jump like into the mega ohms. But if we reverse polarity, which should reverse charge some of the caps and other things here on this line, it'll reset us to where we're back in the kilo ohms. Yeah, we're back at 27K. So we're getting 27K on that line there. And then the next 5v7 line up from that, we are at 300K. Now, since I am in a little bit of doubt on this one, we need to know exactly what those measurements are. I'm going to grab a known working board. Okay, so here we are on a board that I know boots and works. And we're going to put our black probe on ground, and I'm going to use my red probe to check PN5V7 LCM AVDDN con, and we're also going to check PP5V7 LCM AVDDH con. Starting with the bottom one. And on this board that we know should be okay, this one is reading in at 45,000 ohms, which that's what I would expect. And then our next pin up is coming in at just about 1 mega ohm. I'm going to go ahead and reverse polarity on that for just a second, and then put it back and see what that comes in at now. And we went 50,000 ohms and then about 300,000 ohms. Now I'm going to do the same exact measurement here again on the second pin because I want to be sure. And I reversed polarity before taking this measurement because it seems to kind of, you know, for one, it opposite charges all the caps, and who knows what it does inside these ICs. But if I don't do that, okay, see this pin here, this is coming in at 40,000 ohms. I'm going to take my lead off, and I'm going to put it back on, and this time it's going to come in and it's going to test in the mega ohms. So now we're at 7.2 mega ohms, and then once again, if I reverse polarity to discharge all of the caps and stuff I just charged by putting my probes on here, and come back and test that lead, we'll be back in the thousands of ohms. So that's kind of how I get consistent resistance mode measurements that I can rely on to troubleshoot this stuff. However, so we were looking at what, 40,000 ohms on that one, 300,000 ohms on that one. And then our 1V8 line over here is at 12K. So let's kick that one aside. Let's move back to the customer's board. Fixed itself. I'm telling you, this thing had no image, and the third pin up on that right-hand column was like 0.7 ohms. I mean, it was a better connection than touching my probes together. Okay, so the 1V8 is what, 12K? There we go. Same. Next pin up on this one is getting 150K. It's weird, isn't it? Okay, let's discharge. Let's go back. Test it again. 33K. So it's slightly lower. It's 30K instead of 50K. It's a little bit of a better conductor, but for crying out loud, it's 5.7 volts. Like 30K, 5.7 volts isn't going to do squat through 30K. I don't feel like that would be enough to cause no image ever. And then our third pin up, there it is. See that shit? 0.6 ohms, and I'm on the third pin up and the screw hole. So this thing has a really finicky short. Now, I dug in planning on this being like a, hey, look at me fix this real quick type video, but this is the type of bull where I could replace a couple of capacitors and think that I got it shorted or got it fixed, and then this little short popped back up again later because I didn't actually get it fixed. So this one's going to be a little bit tricky, and shit. If I just use, like, my intent for this video was to show you how I just change both caps real quick, or change a couple of caps real quick, but if I do this repair that way, I'm not going to know for 100% certain that I've actually repaired it, because my hot air alone may actually be enough to relieve the short to the point where I'll think I got it fixed, and then this thing's not going to be fixed because this damn thing fixed itself. Now you can see I've got 0 ohms to ground on PP5V7 LCM AVDDH, and I'm going to move right back in here and verify that. And if I put my black probe on ground and I put my red probe on that line, I get 300,000 ohms and then a mega ohm. So what do you say to that? Like, what the? All right. I'm telling you, I looked at this phone last night and thought, this is going to be a good video for tomorrow. This mother... Are you serious? All right, what can it be? Let's switch over to screen capture. We're gonna do our video. I mean, I'm gonna fix this, but something is shorting and unshorting and shorting and shorting. It's the phantom short. Where is the phantom short? And yeah, okay, ZXW is already running in Chinese. I get it. The phantom short. All right, third pin up. So let's zoom right on in here, and we're looking at pin 26. This line here, our possibilities are C2094. It could possibly be C2071. It might also be, okay, and that's on this side of FL2037. On the other side of FL2037, we have got C2050 over here, and then we've also got C2051 over here. It can be any of these, and it can also be the Chestnut IC itself. But these things are a lot easier to find when they're like shorted and not this phantom short shit where, yeah, I said short shit. Not this short shit where it's like there and gone and there and gone and there and gone, there and gone. Is it shorted right now? Like right now, is it shorted? No, we're at 50 damn ass thousand ohms, and that's actually a normal reading. So it's shorted and it's not. It's shorted and it's not. Okay, let's take an iPhone 5 shield and lay it over the battery, huh? And I am going to do a little bit of rework on this thing. Well, not yet. We'll do rework in a minute. let's see if I can figure out what's wrong with it, and then we'll do our rework. This is one that I don't want to do rework without knowing which cap that it is. Assuming it is a cap, it could be the IC. I'm sure we've got a path to ground through the IC. Okay. And what I'm going to do here is I am going to take these components down here and clear them off a bit so that I can get to them. And while I'm trying to act like I know what I'm doing, I'm going to decide what I'll do next. You know, it's going to be one of the caps on that line. And if you just take a guess out of here and you put in some voltage, it's sort of a toss-up as to whether or not you're going to get lucky. And that, you know, I might just have to do that on this one. I might just have to dig in, replace both caps, screw with it, screw with it, and screw with it. You know, that might actually be a more practical option. You know, if it's a disappearing phantom short, and this heat shield I put here is ruining my life. If it is just like a disappearing phantom short, then, you know, I might just replace a couple of caps and give it a while and give it a while. But I don't like for things to come back. All right, so it is the possibility of these three, or these two. So we've got cap, and then a inductor here. One cap is on one side of the inductor to ground, the other cap is on the other side of the inductor to ground, and that's how that's wired. If we put in voltage here to either one of the hot sides of these caps, and the short is on the opposite side of the filter is going to smoke. So if we use voltage to narrow this down, there's a chance that we will actually blow the filter, and that's okay. We can put filters on there, but the big thing here is knowing whether or not this thing is actually fixed when it's fixed. Because it seems to fix and break itself at random. So I'm putting my black probe on ground, and I'm putting my red probe back on our suspected short, and we are still at 50,000 ohms. Can I be bumping ground next to this? Like, I could have been bumping ground over here, but I don't know, man. I could have been bumping ground here. Am I an idiot? Was I bumping ground there? I could have been. And then if I come at it up here to 80, I'm getting somewhat normal readings here. Let's reevaluate my situation here on life. Let's think about this, because if I'm totally wrong, and I don't want to do a bunch of rework on some bull. Why is this phone here? What if it showed up here and it wasn't no image? And I'm a dumbass, and I was checking continuity on that pin, and what could have been happening is I may have actually been checking for continuity here on pin 3, but my pin 26, my probe could have been catching the cap, the ground of this cap. And if that's the case, I'm off. I am way out in left field, and my mistake here will have been completely trusting the description of the repair rather than with the diagnostics, because this is a phone that I opened up and it's from a shop. Honestly, I can't say that I opened this up and hook a screen to it and verify that it had no image. I think I opened this thing up and I went straight up the connector with my multimeter, and I found that was shorted. So what if I'm touching that cap? So let's take this just a little bit differently. Let's take a different approach here. I am going to grab, not sure if I'll need this. Let's use a known working iPhone 6 battery. I'm going to use my multimeter here to measure the voltage of this battery. This battery is at 0.00 volts. Okay. I handed out my charger. Ah! If I hook up the charger and then we check this battery for voltage, we get 0.02. I'm going to get my multimeter sort of up here at an angle. I'm going to show you that under the microscope. We're going to check the 5 volt USB rail. We are at 5 volts. I'm going to disconnect the charger, and I am using a USB current meter here that you can't see, and I can tell you that the reading just now was 0.00 amps. Okay, with the battery disconnected, I am going to go ahead and hook up the 5 volt USB line once more, and I'm going to check voltage right here at the battery terminals. And we are getting 0.29 volts. So it was sent here for no image, but this is going to wind up being a TriStar repair. Wow, gosh, aren't you glad I didn't try to act like a cowboy or like a renegade and just dig in and replace all those caps and assume I would have done all that shit for nothing and still had to do a TriStar IC replacement. So let's go ahead and begin this TriStar repair. The first thing I'm going to do in a TriStar repair, I'm going to remove the board from the phone. Dun da 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 da. So what we got there is we got 5 volts USB coming to the 5 volt USB rail. There is the possibility that this is the dock connector. So once I get the PCB out of this phone, I'm going to take it and immediately drop it into my test housing, and I'm going to hook it up and see if it'll charge the battery. I really should just plug a dock connector into it before pulling the PCB. That would be extremely intelligent, but I'm not going to do it that way today. This did come from another repair shop, so I'm assuming that they have tried everything they can, but I can tell you I haven't went back and read the ticket, but I opened this package and began this repair with the full-on intent of doing a no image repair, and whenever I checked the pins for continuity to ground, I came up with that line shorted to ground, and me being over anxious and always running into that situation, like that's a very, very, very common fault, I just assumed that that's exactly what we were up against, and it wasn't. It totally wasn't. Alright, so we've got, that's our bottom right screw, that's this screw, that's this one. Come on now, we don't need to keep our screws straight. This shit don't even matter. We could just take this big old long one right here and stick it in any hole, and this phone would be fine. Alright, so we got all those screws. Let's get our antenna disconnected. Go. Let's get these cables disconnected. Gosh, this was supposed to be a really quick, upbeat video, and it's going to turn out to be something where I dig in troubleshooting some shit that's not even wrong with it and wind up replacing the TriStar IC. So here is your iPhone 6 no image repair. Of course it don't get an image on the screen because it's kind of hard to get an image on the screen. What? All right. Let's put this in a housing, because seriously, if this thing had a charged battery hooked to it, it should have gotten an image on the screen. Like, why would it not get an image on the screen? So it makes me wonder if a dot connector was actually tried. It's very possible that nobody actually tried a dot connector. And if that's the case, and I replace TriStar IC, I'm going to feel like a complete total dumbass, because you can get 5 volts at the 5 volt USB rail and it not be TriStar. It can still be the dot connector. So let's drop this in my test housing here. That. And I'm going to hook 5 volts to the 5 volt USB rail without a battery. And I'm going to check and see what we get coming out of the battery rail. We get a quarter volt, 3.34 volt. Okay, so dot connector makes no difference unless I'm just extremely unlucky, which does happen, and the dot connector in my housing went bad. Hopefully that's not the case. So I do in fact believe that we are going to be repairing a TriStar IC fault on this PCB. Run me in circles, all because I decide to click the fucking record button. No, because I actually tried to plan one. This is like one of the first ones I thought, that 5v7 line shorted, and I'm gonna do a video on that one. Now I wasn't gonna try to hide it. I was gonna admit I've already looked at this one. This is what it is, but just as sure as I do that, surprise! All right, before I heat this board up, I am going to switch over to the 2027 handle, because the TriStar IC needs solar-like temperatures. Alright, we're going to put our little J-tip away. The tip that I'm using right now, this is a T15-BC1. It's not actually beveled, it's more of like just a flat wedge. Alright, so we've got Hacko heating up. We are not going to need the DC power supply anymore, so let's put all that garbage away. And the next thing I'm going to do here is I'm going to pull the shield off of this board. And to do that, I like to hold it just like that and let the weight of the board remove the shield. Now my air is at 390C and I'm at 42%. Well, 42 out of 99, so I think we can safely say 42%. And I hear it popping and cracking here any minute. We have now removed it. Okay, now while this board is extremely hot, I like to go ahead and begin my rework on TriStar, because that area of the board takes a shit ton of heat to deal with. So while that board is still hot, I'm going to pull the microscope over here. I am going to use my X-Acto blade in my right hand. I'm going to use my hot air in my left hand. And I'm going to keep this hot. And I'm going to begin carving out around our TriStar IC. Now, I like to get in between these surrounding components, at least somewhat, because I think some people probably wind up pulling those off with TriStar. And TriStar is also a really easy one on the iPhone 6 to tear pads. Now that I've done that all out of focus, so anxious to do it while it's hot, I forgot to focus. Okay, I've pretty well cut around the TriStar IC. The next thing I'm going to do is start warming this up for the kill, and I'm going to take my blade here right under the corner, and I'm testing for melted balls. Like my blade will be up, there we go, that solder's melted, you can see it. And from there, it's not much longer, you'll start to get a little give out of this IC, and you can just gently flip it up off the board like that. And it takes a little bit of finesse to be able to do it like that and not tear any pads. So my next step from there is to go ahead and add some flux to the situation. And I'm going to take my big ass tip on this big ass iron set at about max temp. I'm at 840 Fahrenheit. And I'm going to move in here and I'm going to shove some of this adhesive around and also flatten the pads and tin with leaded. So now that we've got those pads flattened, I'm going to take a tiny bit of 99% alcohol here. And we're going to clean this area down. What I'm looking for here is no obstacles. We don't want anything that's going to hold the IC up off the board. And this stuff out here probably doesn't matter a whole lot, but we're going to deal with it anyway. It normally wipes away with just the Q-tip. So usually just really minimal manual cleaning here on TriStar. These iPhone 6 TriStars, they come clean really easy. The biggest bear to deal with is the amount of temperature that it takes. Is it that bad out of focus? Okay. An autofocus microscope is going to be in my near future. Okay, we've got a new strip of TriStar ICs here. Now, from what I've seen out of the TriStar IC, I think it might actually be possible to have a no image situation caused by this little prick. So I don't know, maybe this company, maybe the shop did have like some sort of weird image issue. It's also possible that I read the notes completely wrong and checked it in as a no image problem too. So, alright, we've got TriStar, or our orientation is correct. I'm going to set that aside right here. I am going to add a little bit of flux to the PCB. And we're going to begin lining up the IC. Okay, I'm going to let the chip quick flux do its work here. You give it a little bit of heat and it will tack it down, and then it'll hold still for you to blast it with hot air. Alright, so let me make sure I'm in focus, since everything else in this entire video is not in focus. And we're going to start heating this thing up for the kill. We're waiting for it to move, because unless I was just ridiculously perfect, it'll move a little bit when this melts. And sometimes I am ridiculously perfect, but usually not. Don't expect it to move until the flux bubbles. There, I think we moved a little bit. I'm going to give it a little nudge. See it snap back? That's what you want. A little snap back. That lets you know that everything else underneath it is melted. Now, while this board is still hot, I'm going to spin around here and I'm going to clean it with alcohol. Because Chip Quick SMD 291 flux really sucks to clean up once it's cooled. Ah ha ha! TriStar! Okay, so after cleaning the PCB, since I'm overly confident, I'm going to go ahead and reattach the shield, which also serves as a really nice drying process for the alcohol I just used to clean it. So to reattach the shield, I'm just going to line up all of the screw holes. Like that. I don't know how autofocus is going to do for us today, but we're going to lay the, we're going to put our faith in autofocus. Autofocus, I give you the keys to the kingdom. Don't fuck it up. There we go. We're going to let that cool. And all I did, I just watched for it to, you know, you can see it when you touch it. You can see the little bit of motion in the liquidous solder. And that's what I watch for. And as soon as it's liquidous, I take the heat off, and we have a nicely, really solid attached shield. So let's go ahead and fold our cable back here. Hopefully we're done with the hot air. Nice little rotate back and forth. That thing is solid. That's solid. All right, so let's go ahead and pop this back in the housing. Remember, their battery was at 0 volts. So what we're going to do here is see if this thing will pop that battery back up off of 0 volts. All right, let's get our antenna cable out of here. For a minute there, I thought my button said stop or start recording instead of stop. I did that the other day. I recorded a really good video. It would have made a good video. But whenever I went to hit the stop button actually said start, which means I never clicked it to begin with. Smooth. Alright, I'm going to go ahead and hook up our antenna cable down here because I don't want it to accidentally touch VBAT, which will give you a very similar set of symptoms. Tell you what, since I'm recording, I can't plug in one of these cables. I should just do that under the microscope since I'm practically blind without it anymore. Okay, we'll put in its guide. Alright. And just for giggles and shits, we're going to connect a screen. That. And we're going to drag our excruciatingly short charge cord over here because somebody, not mentioning any names, has stolen my long charge cord. Alright, so we're going to plug in... Let's do this with the battery hooked up. And let's retake this measurement since I'm recording a video. With the battery hooked up, I'm going to put my black probe on ground, I'm going to put my red probe on VBAT, and I get a 0.5 volt. RS-232. Alright, let's restart my connection to this meter. And I'm going to put my black probe on ground. I'm going to put my red probe on VBAT, and I get 0.27 volts. I'm going to go ahead and connect 5 volts to the 5 volt USB rail and hope I didn't grab my bad lightning cable. And we get 3.3, 3.4, 3. We have a steady rising voltage, which tells me that this thing is absolutely now charging the battery. The USB current meter is at 0.9 amps, so we're just under an amp of current. And I bet you if I flip this screen over and I push the button, we get a battery on the most brilliant screen at the bench right now. We get a charging battery icon. So, we have normal charging current. We have working image on the screen. We have a phone that was sent here labeled for image/iPhone. Man, this is a solid. Tried battery, tried screen, tried charging port. Still no picture. What could have happened here is that the battery that was tried might have also been flat dead. And if that's the case, then this thing still would have wound up with no picture on the screen. The only way that this set of troubleshooting, this one says it tried battery, tried charging port, tried the picture. The only way for this set of troubleshooting to have really revealed this is if the battery itself that was tried was known to be charged, because I think that would have powered on this phone. This is a classic TriStar failure that ran me in circles, because I'm so used to iPhone 6 and 6 Plus no image situations that this was just like, no image, give me it. And it wound up being TriStar. So let's see. Gosh, let's finish the repair. Let's put this back together. I'm going to go ahead and disconnect our charger because it's charging the battery. Freaking no image. I am so no image happy. It's just like, cool, let's do another no image repair. Yeah. Wrong surgery on the right patient. That would have been just brilliant. So we're not going to pay any attention at all to the direction of these screws. This little tab up here seems to be misformed. We may have to pay that a little bit of love. But it may also make a sufficient connection, so I will deal with that in my own time. Always feeling for anything weird. You just never know. You'll start putting this stuff back together, and something will feel weird, and you'll go and actually check it, and it winds up being a screw or something under the board. And man, oh man, are you glad that you didn't crank it down and just tighten that screw tighter, because that would turn a really, really basic repair into a total nightmare. Alright, so let's get this little antenna dude back up here. That. We're going to loosen this one just a fuzz to allow the rest of these to line up. Sometimes if you tighten one down tight before moving on, you'll wind up with things all kinked up and wadded up. Wow, throw me off guard. I actually planned for this one. Like, I planned for the 5v7 line to be shorted, and I wasn't going to hide it. I was going to admit it and just kind of walk you through how I narrowed that down. But what I actually did when I took my measurements, I was shorting my big fat probe to the cathode side of the capacitor nearby, giving me a false reading that excited me over a shorted chestnut line. So let's see, that's all that. And I don't think we've tried this with their screen. It's possible that all of this could have been complicated by the screen also being bad, and multiple things being wrong can really run somebody in circles. So let's fully reassemble this with their screen. Their battery. Dun, da, 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 da. Yeah, ever since I started doing all this mouthing about the prior repair attempts, it has really slowed down. And I am thankful. I can fix a lot of stuff, but when it starts to get to where every other one, or like every 3 in a row are nasty, ugly, really screwed up messes, and then you get one that's not been worked on, and then 3 more in a row that are just total train wrecks, and then one that hasn't been worked on, it starts to be a really big deal. Like, there for a while, I was higher than 65%. I mean, seriously, it was like sometimes almost 3 out of every 4 devices that came in were really royally screwed up prior repair attempts. So it's just, oh my gosh, I was thinking, how many YouTube videos did I post where I was fixing somebody else's fuck ups? Oh no, I mean, I'm about to take anything offline, but still, what did I do to myself? So, All right, where are we? We've got everything put back together here except for the pentalobe screws. I see this one only has one pentalobe screw with it. And in the world of iPhone repair, one of the best stress relievers that I have found yet is a bag full of pentalobe screws. You just can't beat having a steady supply of pentalobe screws. So let's get our pentalobe screwdriver down in here and let's pull us out a little wad of these things. And hey, we actually got the right color today. So let's take the one that he sent with the phone. And we'll put it back in the phone. And then we'll take one of mine and we'll put it in the other side. The repair ain't complete until it's got the pentalobe screws in it. So, I probably like way overpaid for this. I don't remember. I paid like $5 or $6 for 100 of them, which is plenty for me. So there we go. Pentalobe screws back in the package. The phone is all put back together. The charging current with the phone fully reassembled is now at 0.92 amps, and we have a charging battery icon. So I think what we have here is a phone that had a bad TriStar IC. Through the troubleshooting steps that were taken before it was sent here to me, it was tried with another battery, but it wasn't tried with a battery that was known to be charged. That's what I think. And I think I was just a dumbass and was checking that line wrong. So, cuckoo. Anyways, guys, that's going to be it for this repair. This is going out the door working, and I don't have to eat out of the trash can. So I'll see you next time. Thanks for watching, everybody. Have a good day.